Hi, in this chapter 3, we will talk about control statements, assignment, plus plus and minus minus operators. So mainly it's talking about if else and also the loops, part of the loops like while loop. So if else is written in the same way like it's written in C++, exactly. Same like while, it's exactly the same way. So actually nothing new in this chapter. That's why we will go fast for the slides. So pseudocode, we know pseudocode is a way to write algorithm. So if student grade is greater than or equal to 60, print pass. This is how it will be written in C++. As you notice, it's exactly, sorry, it's in Java, it's exactly like it's written in C++. So this is if else concept, we know it, and again it's written exactly the same way like in C++. That's why I will go fast over this concept. You can have nested if, like if else, and inside else you can have if else, and inside else you can have another if else, and so on. But the best way is to write it like if, else if, else if, else if, and then at the end else. So same way like if you have one statement after if, it's optional to make braces like this, but if you have more than one statement you have to make braces to make it as block. This block is belonging to the else. So we have sometimes like syntax error, and we have also logic error. Sometimes it's not like something wrong with the language, but imagine you didn't make these braces. Okay, so it's not syntax error, but it will be understood in a different way. So this statement, the first statement, will be belong to else, and this statement will be outside the else. It will be executed anyway. So this is called logic error. So you find this error if it happens when you run the program. So don't make semicolon after the if statement. This is logic error. We know this from C++. And it's like, make sure that you don't make infinite loop when you make a while. By the way, this is like while, it's written again the same way like in C++. So nothing really new. Try to avoid infinite loop when you write while. So how it's working while, let's talk more about this example. So remember, this is comment. This is import java.util.scanner because this program will contain input from the user. So we have to use the class scanner. So we have to import this. And then public class, we call this class average. And then inside the class, we said inside the class we make a main method, public static void main string args, and this is the start of the main method. Here we define the scanner, we declare the scanner, we create the scanner import new scanner system.in, and here we define a variable of type integer and give it initial value to be 0. We define another variable called grade counter 1. So the idea of this program is that we want to add numbers to print the total of many numbers that we read from the user. Okay, so the total initially is 0, and we count how many number we have so far. So we start with 1. While grade counter is less than or equal 10, so this loop will go 10 times because the grade count is 1. The condition is less than or equal 10, and every time I increase 1. So this loops will go 10 times, this while loop. Every time in the 10 time I ask to enter the grade, I print enter grade, and I ask the input from the user, and then I add that grade what the user entered to the total. So at the end of this loop I will add 10 numbers. After the loop I will compute the average by dividing the total divided by 10, and then I will just print new line. Total of all 10 grade is some number like integer and then a new line, and this integer slot I will print in it the total, so the total of all numbers. And then I also print if class average is this slot for the number and the new line, so the slot is booked for the average, which is the total divided by 10. So let's see example. Because of the while loop, this will run 10 times, asking the user 10 times to enter grades. At the end, it will print total of all 10 grade is the total of these numbers and then the average of these numbers. So this is example for a while loop. So and just like nothing new, it's explaining the previous example. Here is another example. So let's see, this example is similar to the previous example, but we don't make loop 10 times. We don't know how many grades we have. So every time we ask enter grade or -1 to quit. If you enter a valid grade, it's continue. It's stop if you enter -1. In this case, it will make the total of these valid grades and then compute the average of them. So let's see the code. So the code is similar like previous one. We import scanner, we define the class, we define the main, we create the scanner, and here same thing. Total is 0. Here we make grade counter 0 and not 1 because for the first time we want to read the grade. So we print enter the grade or -1 to quit. This is before the loop. We read the grade from the user, and then inside the loop we check if the first grade was -1, we quit the loop directly because the user didn't enter any grade, and in this case we will not print anything. Okay, but the grade, if the grade was not -1, this means the user enter a valid grade, so we will add it to the total and we will add the counter by 1, and then we will ask the user again enter grade or -1 to quit, ask the user for the grade and repeat. Okay, so at the end there are two cases. If the user directly enter -1 from the first line, then we should not print anything because he didn't add any grade. But if this is not the case, first we compute the average by the total divided by average. We make double because we want to so here is integer division, integer divided by integer, the result is integer, but we want the exact division, so we make a double. We make this total to be double and we store it in a double, and then we print the total of d grade is, so we make a slot for some integer, is d another slot for another integer, a new line. The first slot is grade counter, so if the user enter 3 grades, we will print here 3, and the second slot of total, it will just add the numbers. In the second printf, we write class average is, this is something new, percentage dot 2f and then percentage n. So in this case you want to make a slot for a float number or a double number, and this double number you just need the first two digit after the decimal points. That's why you write dot 2f. Dot 2f, you make a slot for a float number and you want to format it to show only the 2 digit after the decimal point. So if it's 3.33333, it will be printed as 3.33. That's it. And this is the average, which is a double, because I promised to make a slot for double, which is average. Double means float. There are two types, we'll talk about them later. So here is, and then else, otherwise we will just print no grade were entered. This is in case grade counter was 0, so it will goes to the else, and then we print no grade was entered. Imagine we run the program. The user entered 97, 88, 72, and then -1. It will print the total of 3 grades enter is blah, and then the class average is this one. You can see it's formatted to only 2 digits after the decimal point. If we didn't make 0.2f, just if you make f here, if you make %f, you can make this. It will show 85.666666666, and it will be ugly. So this is why we use printf actually. If you use a print or print line, you will not be able to do these nice things. That's why the people told me we hate printf, we want print and print line. I say in some situation you need printf actually. Something like this. Okay. Yeah, so this is just explanation of that example, and we talked about this already, this 3.333. If you format it like that, it will be 3.33 and so on. Here another example. Let's see what example is. It will ask the user to enter 1 or 2. 1 means pass, 2 means fail, and it will go for 10 iterations. So it asks me about the first result. I say 1, it's pass, fail, pass, 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 pass. At the end, the program should count how many pass I pressed and how many fail. And if 8 or more student pass, I should give bonus to the instruction. I will print bonus to the instruction. So this is another run of the program. Many failure. There is no bonus to the instruction. Okay. So let's see the example. You import scanner, you define class analysis, the name of the class, you define main method, you create scanner, and then you define 3 variables. You need passes 0, failure 0, you want to count how many passes and failure, and student counter, you want to start from 1, and the loop less than or equal 10, so it will go 10 times. Every time you will print enter result 1 equal pass, 2 equal fail, sorry, and then you read input from the user, and every time inside the loop you check if result equal to 1, you add 1 to the pass, otherwise you add 1 to the failure, and you increment the student counter, and so on. This loops will go for 10 times. After that you will print passed, how many, you make slot for a number, integer, and new line, fail, you make slot for integer. The first integer is passes and second integer is failures. If the pass is more than 8, you just print bonus to the instruction, and these are the runs that we explained at the beginning. So you know, like same like C++, C equals C plus 3, you can make it like C plus equal 3, same like minus, division, multiplication, remainder. We can use plus plus, minus minus, you know this from C++. So let's see this toy example. We have defined class method, we define integer c equal to 5, and then we print f. We print first c, it will be 5, right? C++, it will print the old value of c, which is 5, and then add 1 to c. So after this, after printing 5, c will be 6. And if you print c again after this, it will be 6. So it will print 5, 5, 6. Here, we start again c with 5. We print c. Here, plus plus c means add 1 to the c and then print it. This is the difference between here. So here it will print 6 because it will add 1 to c and then print it. If we print c again, it will print 6. So 5, 5, 6, 5, 6, 6. This is the difference between plus plus c or c plus plus. Okay, so these are the precedent of operators. We have primitive data types in Java. We'll talk about them later in detail. Actually, we have 8 primitive data type: character, char, byte, short, int, long. All these 4 are for integers. We have float and double for doubles, and we have boolean to store true or false boolean. We will talk about them later. I think that's the end of this chapter.